What is logistic population growth? Have you ever wondered how populations grow and what limits their expansion? Today, we will discuss logistic population growth, a fascinating concept in demography. Logistic population growth is a model that illustrates how a population can increase rapidly at first but eventually slows down as it reaches a maximum limit known as the carrying capacity. This carrying capacity is the largest population size that the environment can support indefinitely based on available resources like food, water, and space. In the beginning, logistic growth starts with a small population size. During this phase, resources are abundant compared to the number of individuals. As a result, the population grows almost exponentially because birth rates are higher than death rates, and there are few constraints. However, as the population size increases, competition for limited resources becomes more intense. This competition causes the growth rate to gradually decrease. Eventually, the population stabilizes around the carrying capacity. At this point, the number of births equals the number of deaths, and the population reaches an equilibrium. Mathematically, logistic population growth is often represented by a differential equation. This equation is expressed as dn/dt equals Rn multiplied by 1 minus n divided by k. In this equation, n represents the population size at a specific time, r is the intrinsic growth rate, k is the carrying capacity, and dn/dt is the rate of change of the population over time. As the population size n approaches k, the term 1 minus n divided by k reduces the growth rate, reflecting the impact of limited resources. When graphed, logistic growth produces an S-shaped curve, also known as a sigmoid curve. Initially, the curve rises slowly, then steeply during the rapid growth phase, and finally levels off as the population nears its carrying capacity. From an anthropological perspective, logistic population growth models can be applied to human populations to understand how environmental constraints and resource availability influence demographic changes over time. Anthropologists utilize these models to study historical population dynamics, migration patterns, and the effects of ecological factors on social structures. For instance, when a human population grows in a limited environment, factors such as food supply, space, and technology affect the population's growth rate and sustainability. In quantitative anthropology and demography, logistic growth models are essential for predicting population trends and understanding how human societies adapt to environmental pressures. This approach integrates mathematical methods, such as differential equations, to quantify population changes and their relationship to resource limitations. This is vital for studying both past and present human populations in their ecological contexts. Understanding logistic population growth helps us grasp how populations interact with their environments and the factors that influence their survival and expansion.